Looks like we're live and we're off and running. Hi, everyone. My name is Emily, and I'm the community manager here at 2 Diabetes, working with Diabetes Hands Foundation. And today we are meeting with Dana Lewis, the co-creator of the Do-It-Yourself Pancreas System. And this is super exciting. DIYPS has been on fire on Twitter and social media in general. And so we thought we would meet one of the creators of it and learn what this thing is. Dana, camera's on you. Thank you so much for being here today. First off, who are you?
Thanks for having me, Emily, and thanks for everybody who's tuned in. I know there's been a lot of conversation and interest in learning about this. For context, I have type 1. I've had it for about 13 years. I grew up in Alabama, was diagnosed there, now live in Seattle for the past 5 years. So I've kind of met people all over the country and learned a lot about how other people treat their diabetes, but I also have strong opinions about how I treat mine. I've had a pump and a CGM for a very long time, but I have a very common problem that I sleep through my CGM. So as a result, we built a louder alarm system, which we call DIYPS, which has now evolved into a fully closed loop artificial pancreas, which I know a lot of people want to hear more about today. But that's where I'm coming from, is the perspective of having built the system, DIYPS, but then also having lived with a closed loop for the past year.
Wow, a lot of us would consider that kind of a dream come true, to be living with a closed loop. But before we talk about the dream come true and whether it is a dream come true, in fact, first off, I think it's hilarious that you set out to make your alarm louder, and then, oops, I made an artificial pancreas in that effort.
Yeah.
How on earth did that happen?
Well, it came about from the same situation that you have when you talk to people about diabetes devices. So I met my now husband on our first date, and I pulled out my pump and went to do a bolus just to kind of do a subtle, let's bring diabetes into the conversation. And as he started learning about diabetes and devices, he asked the same question everybody else does. Wait, that device and that device don't talk to each other? Why not? And can we fix that? And I kind of explained, nope. At the time, 3 years ago, we couldn't fix it. But what you could do is, if you could get the data off, you could then do all this really cool stuff. And so over the first 6 months of us knowing each other, and we talked more about it, I was saying, if we could only get the data off the CGM, we could build a predictive algorithm that would alarm and wake me up, but could also alert you or anybody else. Now, for those of you who are familiar with something like CGM in the cloud and the Night Scout project, this is going to start to sound really familiar, but this was before Night Scout even existed. So about the same time, John Kostick had figured out how to get the code off, or the data off the CGM, and had posted on Twitter about it. So we had reached out to him and said, hey, would you be willing to share your code of how do you get your data off the CGM? Because I would love to do something with it. He shared that code. And it was kind of, if you give a mouse a cookie, we said, well, we can get the CGM data off. I want to get an alarm. Well, it'd be great to alarm somebody else if I didn't respond, but I don't want him to get alarmed every time I go above or below the yellow and red lines. So we added buttons that would snooze these alarms. And because I was putting in all this data of I was taking action or not to let him know whether he would need to intervene or not, we were able to build this real-time prediction algorithm that says, because you're doing this action, and your blood sugar is this and changing, you're going to have this happen in the future. And so if you take action now, you can prevent or delay that from happening. And so that's how we went from just get the data off to this predictive alert system.
What background do you and Scott have? Tackle this?
Yeah, so I have kind of a hacker mentality. I grew up in a house full of engineers, and so I don't consider myself an engineer formally, but I do a lot of the same work that an engineer or programmer or developer does. Scott has a engineering background, but it's more network, content delivery network, so more on the back-end infrastructure side. But he also has the same mindset of, let's figure out a way to make it work. And that's what I think is one of the phenomenal things about going through this experience, and something I want to talk about as we talk about the closed loop, is people often say, oh, you must be an engineer. No, you don't have a background, you don't have a formal training, because these products don't exist. It's about saying, I have a deep understanding of diabetes and how I want to treat it, and how I want to teach the computer how to give me these alerts and responses. It's basically taking the same math and the same thought process you or another person with diabetes does, but teaching the computer what that process is. And so that's more about basic logic and diabetes treatment, and it's not about being an engineer.
Incredible. So we already have a question for you in the chat room. which is, are you posting the details of the design somewhere?
Yes. So there's a difference here. We have what we call DIYPS, which is that manual alert system that I originally built. And so you can go to DIYPS.org and read about how we built that system, first being the louder alarm and the alerts, and eventually it evolved into a closed loop. But there's a lot of details and a lot of lessons learned there. We can't post the code because it makes recommendations about dosing off of a CGM, which we know is technically a no-no. You shouldn't be doing that according to the FDA. So we can't post that code, but we've been posting a lot about our experience learning it, and about some things that you could potentially take and do with your own treatment manually without having to have this system. Now, the other side of the coin and the other answer to this question is about OpenAPS, which is the open source movement to make this kind of technology more available. So we went from closing the loop with DIYPS to saying, we do want to make this available to more people, but again, we can't just give it away to somebody because that would be distributing. There's a lot of reasons why we can't do that, but we want to make this kind of thing possible for other people to build. So if you look at openaps.org and some of the links that I posted, you'll see the reference design there that it walks through in plain English. This is the type of thing that a closed loop system, if you DIY it, is likely to do, and some of the things you should think about before you do it. And we can talk more details about, there's code available, there's instructions available to help you start working through the process. It's not 100% line by line. This is exactly what you can do, but it's like a series of building blocks. Here's the tools. Here's some of the safety parameters and constraints you need to think about. And then that will help you alongside the community to go off and build your own system if you decide that that's something you want to do.
And do you know other people who have done that and are using those systems now?
Yes, and there might be some in the chat room today. There's actually about 25 total people using OpenAPS, and I hope if you're listening, you join in the chat and share your experiences too. And it's been really interesting because I closed the loop for myself in December of 2014, and we decided we were going to launch this OpenAPS thing in February, but we didn't really have anything documented. We just kind of put a stake in the ground and says, we're going to figure out a way to make it so other people can also do this. So over the first couple of months, we worked really hard along with others in the community, Ben West, who's been an integral part of this, and some other people to start building these documentation and putting these building blocks into a better place. And you really didn't see a lot of other people close their loop until June, July, August. And then the documentation started to get even better. And so we've had a flurry of people over the last 6 months. So we've gone from about 6 or 7 to 25 in the course of about 6 months who were able to do their loop and go live with it.
And what kind of experiences and results are you hearing from those other folks?
You know, a lot of the pushback I got as I talked about even DIYPS, just the manual kind of open loop system, was, well, that's you. You're designing a system for you. That's great, but it's not going to work for anybody else. So as we started doing OpenAPS, we were saying, you know, it's not a big machine learning complicated thing that's tuned to Dana's body. It's if your blood sugar goes up, you need more insulin. If your blood sugar is dropping, you need less insulin. And yes, you have your ratios and your sensitivity factors based on how much insulin you need and how much food you need for various things. But that's the only really tuning that is done for an individual body. Otherwise, again, it's basic. If you go up, you need more. If you go down, you need less. But still, even with that in mind and that belief that it would help other people, I have been really thrilled to see other people share their positive experience and say, somebody said yesterday, was as life-changing for them as getting the Dexcom. And this was a parent who's done this for their child, and to be able to have this help with dealing with overnights or sending it to school. You know, personally for me, I had a very big fear of sleeping through my CGM alarms. That's what, again, started all of this. And so the peace of mind of having something that will wake me up if needed, but also instead of waking me up, it'll actually just do what needs to be done. I still have those wake me up alarms as background and as a really, you know, high level safety setting. But if I start rising overnight or I start dropping, it's going to adjust the insulin levels on my pump using a temporary basal rate. It's very safe. It's very effective. 9 times out of 10, I wake up between 100 and 120, have had a perfect night. And the first thing I don't do anymore is think about, oh crap, what was my blood sugar last night? What happened? This is why I feel bad. It's hey, what's on my plate for the day? And that mindset, I never expected I would be able to have that mindset, because when I was diagnosed, you know, diabetes was just the first thing you thought about in the morning. And now it's, for me, it's not anymore. And that's just a really phenomenal change.
That, you know, that's a piece that I hadn't really thought of coming up to this interview, is that there's a whole psychology also around taking some of this work off of your own plate. But so I want to make sure that I understand. Do you still have to program anything? Obviously, you have your own personal settings and things like that that I imagine can be sort of set once and then it's done unless your insulin to carb ratio changes or something like that.
Mm-hmm.
But throughout the day, what kind of interaction do you need to have with your machines at this point?
Yeah, I am still meal bolusing. That's probably the biggest question I get is, oh, can I not meal bolus anymore? We tried building the system as a way to not have you meal bolus, but it's really hard to do without some kind of meal announcement. And as you start to think about some of the other AP systems you hear about in trial, a lot of them will have at least some kind of, hey, I'm starting to eat, to kind of give the system a trigger to ramp up the insulin activity. So what we've decided to do is also to make this as safe as possible. You'll hear us talk about this a lot, is that we are doing the absolute safest thing possible. And that is to still have the person do their normal meal bolus or their meal bolus strategy, whether you do multiple boluses or a square wave bolus over time or something like that. But you need to do that initial bolus to take care of your meal. The system will see that, and it's not going to counteract it by saying, oh my gosh, you have too much insulin, I'm going to drop your insulin. We do what we call a bolus snooze, that if you bolus, whether it's for a correction or a meal, it's going to say, okay, we're going to readjust what we think is going to happen. And over time, we'll eventually kick back in and ramp up. And the good thing about that is it's not going to counteract your meal bolus. But say you were off your carb estimates by about 15 grams, or you went for a walk after lunch, or you got excited, you were in a meeting for whatever reason we know, your blood sugar might change. And so if you're going to go off the trajectory of what the system thinks is likely to happen based on carbs or just purely insulin activity and the BG trend, then it's going to kick back in. So it's kind of that nice tail end. Let's just help at the end of the meal, but let's take care of the beginning of meal. So to answer your original question, I still have to do basic diabetes care. I'm still testing my blood sugar multiple times a day to calibrate the CGM. I'm still dealing with, insulin pooling under a pump site and that kind of thing. And I still do meal bolus. But I'm not worrying going into the night about slowly dropping and worrying that I'm going to go low when I need to eat a snack. I'm not waking up to do that. And kind of during the day, I can sit down to something like this and not worry about what my blood sugar is, because the system is sitting over here by my side, going to be responding to if my blood sugar starts dropping or rising. So it's not a set and forget, but it allows you some more concentrated periods of time to live your life the way you want to. And then to help you, so if you do make a spur of the moment, oh, this looks about 60 carbs, I'm going to bolus 6 units, you're not, you're still doing that and you still want to make good decisions, but there's less pressure to get it really precisely right. Interesting.
So you just held up some sort of crazy looking data board. I'm not much of a techie, obviously. Can you show that to us again and explain what it is that we're seeing?
Yep. So first of all, this is just a battery. So it's fairly big and bulky, but it's because this is like a 12-hour battery that will last all day. Now it is powering this computer board, and it is a Raspberry Pi, which is a little mini smart computer you buy on Amazon for about 60 bucks. And it comes with this case. The other things that are connected to it are my CGM. So it's just plugged in, so you don't have to have internet connectivity to be able to deal with it. And the Raspberry Pi is going to pull the data off from this without requiring internet. And then the other key component plugged in is the CareLink stick that's going to talk to my pump. So as long as my pump is somewhere within about a 3-foot range of this stick, it's going to read data off my pump about how much insulin I have. It's going to read the BGs from my CGM and say, you're writing at 137, that's a little bit high for you. You might be needing a little bit more insulin. This is going to talk to the pump and give me a temporary basal rate, which right now, yeah, I've been running a temporary basal rate for the last 12 minutes at a little bit higher than normal, because 137 is a little bit high for me now. All that's been happening since we started this discussion 14 minutes ago.
That is incredible. So in the chat room, there's a lot of discussion right now about the Raspberry Pi and about what pumps folks are trying to hack into to make this system work. Can you talk about what other gadgets folks are trying to apply this to?
Yes. And so the short answer for what pump works right now, I want it today, go to openaps.org, link to our docs. There is a section called hardware, and it has a list of the pumps that are going to be compatible. You'll hear us talk a lot about the older generation Medtronic pumps, because it has to be an older pump where this security hole is not closed. So it's a 522 or older pump, that's going to work. Some of the 523s will work. So if you've got an old 523 sitting around, check it. If it's a 2.4A or below, it might be working. The easiest way to tell if your Medtronic pump will work is go to Utilities, Connect Devices menu. If there's a PC Connect option on there, it's not going to work. But if that PC Connect is missing, it means you've got an old enough pump where that's going to work. So the reason we have this able to work is because Ben West, who's been amazing, figured out how to make this CareLink stick talk to these older generation Medtronic pumps. And he spent years working on this device communication and has continued to dedicate himself to doing this, which has enabled us to close the loop, taking our algorithm, talking and reading to and from the pump, and being able to actually close the loop from that. There's a lot of questions that I always get about, well, okay, that's Medtronic pumps, what else? Well, I talk about it because had he not done that work, we wouldn't have been able to close the loop as quickly as we did or at all. We have people who are working on similarly understanding the communication of Omnipod and Animas. Those are the two we most frequently get asked about. I haven't seen anybody do it yet, but again, there's work with Omnipod. There's somebody who's doing a really good job with the Animas Ping. And then the other question I get is about the t:slim. And again, this is all us working to understand the communication protocols. A lot of times it's reverse engineering. The companies aren't necessarily willing to security reasons. So this is all a lot of investigation that people are doing themselves with their devices. And so what I tell people is go to openaps.org and look at that hardware list, like I said. If you're interested in helping with some of the communication, I've got a Slack channel for people to get together and kind of work through Omnipod and everything. So you'll see my email address everywhere, but it's dana@openaps.org. And if you email me, I can add you to that Slack channel or connect you to the right group of people who are working on some of these other communication devices.
Wow. And at this point, about how many people are working on this? Is this like, are there tons of people all over the country who are working to figure this stuff out, or is this like a really small group of people working really closely together on it?
Depends on what you just consider to be a small number of people. So we have 25 people who have loops and who are continuing to iterate. So one of my tweets earlier today showed this Raspberry Pi setup and said, this is what a sample looks like, but that might change. There's actually people working to figure out, are there other devices other than that CareLink stick and the Raspberry Pi that could be used? And the answer is yes. And there's some exploratory options there. And so there's little pockets of people and little pockets of groups working on different hardware, different pumps, and different software components. And we've got people all over the world, some people in Australia, New Zealand, some people in the UK and elsewhere who have both closed the loop, but are also working on exploring some of this stuff. So to answer your question, it depends on what you consider small or large, but there's a group of, several dozen people working on various components of this, whether or not they're choosing to close the loop for themselves. And I think that's really exciting. And one of the coolest things about all this is it wouldn't have happened without other people. We couldn't have closed the loop without Ben West. We would not have gotten DIYPS without John Kostick sharing his code. And the other collaborations we've continued to have been really incredible. And so there's this very much, you'll hear us talk about we are not waiting, which some people may be familiar with, but for those who aren't, it's this idea of we're not going to wait 2 years for something to come to the market. If we can do it right now, we want to do that. And we want to help other people, and we're going to pay it forward. So I may decide to keep my Medtronic pump, but I want to help enable people with Animas and Omnipod and t:slim and other pumps figure out how to make this work for themselves. So I'm going to do everything I can to help enable those people. And you'll see that spirit is just kind of everywhere in this. And that's really, really fun to watch because you're meeting and surrounded by these really great people doing really cool things.
What kind of opposition, if any, have you gotten from FDA or from folks who are concerned about FDA type regulations that might affect the work that you're doing?
We're not getting opposition, and there's some key things to distinguish here, which is one, you can do whatever you want to your own body. So I can, N of 1 experiment, I can do anything I want. I could stop taking insulin and just eat cinnamon if I really thought that's what I needed to manage my diabetes. So this DIY system, this N of 1 thing is totally fine. The FDA can't do anything about it. The FDA regulates commercial products. So if I were to charge you $1 and hand you a system, that would be against FDA regulations because it's not FDA approved. And so that's where we are, and why OpenAPS is an open source project, because we are very specifically not distributing a physical setup. We're encouraging people to go off and build their own. And that's also why you'll see me reference OpenAPS is N of 1 times 25 or whatever that number happens to be to reiterate that these are all people who have chosen to put in this work and build their own system, and it is unique to them. They're not completely identical, even if they're based on the same design. You know, somebody's going to use a slightly different device or a slightly different XYZ, or it might be very similar. But the point being, they are making the choice and going through the process to do it themselves for themselves. It's an end of one thing, and that's not something that the FDA can regulate. We have had conversations with the FDA about, you know, what do you think about these kind of projects versus something like Night Scout, or, you know, little bits and pieces of code that allow you to do an online bolus calculator, and kind of talking through what are the different things that people are working on, and what, you know, what do we potentially want to talk to about getting it FDA reviewed or not. And I think the distinction is whether you're going to be a company or not. So for those of us who are DIY hackers, we just want to help the community. You know, that's not something that needs to be FDA approved, as long as you're not, again, distributing a specific medical device. And there's a lot of gray areas and a lot of questions about that, but we're not distributing something. So we just take the focus of how can we support and enable the community by putting together documentation and pointing people to the building blocks so they can go off and do that one implementation.
We have a question in the chat room from Terry. This is a great one. Terry is asking, how often do you have to tinker with it or fix it, or is it really reliable? Is the system, once you set it, it continues to just work as planned? Or do you kind of continuously have to fix kinks and things?
That's a good question. And my answer is it depends based on your definition of kind of, you know, do you have to fidget with it? When I first closed the loop for DIY-PS, it required internet connectivity. So I would have to walk out of my house, hotspot from my phone to the Raspberry Pi, get to work, plug it in, do all this kind of stuff. I didn't have as good of a battery, and the system felt really fragile. And so we worked really hard to find a way to make it offline so I could walk out the door and the system would keep working and not be reliant on internet connectivity. So we've done little things like that have made the system, I think, more robust. And although you can let it run, you still want to check and make sure it's working. And there's a number of reasons why it might not work. The battery dies, you know, the cord gets unplugged in your bag, you're not close enough in range to it. There's a couple of reasons it might not be working. So it kind of just depends on how reliant you are and how worried you are about things. There's multiple days where I just throw it in my bag, and if it reads, great. If not, I'll get a backup alarm saying if I'm rising or dropping, and I'll deal with it. So it kind of depends on your perspective and on how tightly you want to keep your blood sugars. If I want to make sure my blood sugars are perfect because I'm really preparing for a big event or a meeting, I might be watching a little bit more closely and I might spend a little more time with it. But for an average day, it doesn't take that much babysitting in that regard. And it's pretty much, you plug your CGM in, you make sure you're in range, and you're good to go. But keep in mind, this is the answer from somebody who really knows her system very well, has built it herself, but has also been doing it for over a year. So the burden and the intensity and the frequency that you're fiddling with it, especially as you develop it, there's a long testing phase if you want to watch it to see what it's doing and why, and make sure that matches with what you want it to do. And then even after you kind of get to the, okay, I'm live, I'm not checking everything before it goes, I'm just letting it go, but I'm gonna keep an eye on it. You know, people are gonna watch it a lot more closely than maybe I do, again, a year out with the system. So it kind of depends on your experience, how it's working for you, and that kind of thing. It's never going to be a set and forget kind of system, though, because again, it's dependent on it being in a range. It's dependent on, you know, not getting question marks on your CGM. You know, there's just some normal diabetes stuff that you just can't get around. So just kind of having an awareness of the system, kind of similar you would to making sure your pump didn't rip out of your clothes, and that kind of basic thing of checking to make sure it's in range, it's working, and that type of thing.
And folks noticed when you held up the Raspberry Pi and the battery and the CareLink thing, it's a bit of a cumbersome operation. Although considering what it does, potentially not cumbersome. It might unencumber your brain enough that it's well worth any amount of gadgetry and tubing and everything. But are folks working to try and make it, to figure out a smaller, lighter, easier to carry kind of solution?
Yep, and when I was talking about people replacing the Raspberry Pi, that's a question because for them, the Raspberry Pi, so here's my cell phone, here's the Raspberry Pi. Thickness-wise, it's a little thicker, it's a little bit longer, and then again, depending on the size of your battery, you know, your setup's gonna vary a little bit, but there's people working to replace the CareLink to make, you know, it use less battery power so you can carry a smaller battery. So that's definitely in progress. My bag, just for context, this is what I usually carry it in. It's about one cell phone high, a cell phone and a half long. So for me, it fits, it throws in my purse or my backpack. It fits in men's jeans pockets. It doesn't fit in my jeans pockets. But I can also, if I really wanted to, I could fit it on a belt for when I go running. So it seems big, but it's also, I would say it's about average. It's going to get smaller. But that's something, again, for people to consider. A lot of people say, you know what, that'd be great for overnight. I don't want to haul it around, so I'm just going to leave it on the bedside. Great, do that. And just have it plugged in, and you don't have to do anything other than plug your CGM when you go to bed at night. And that's actually something we've done, is I have multiple Pis. I have a multiple setup going on. So I actually have 1 or 2 Pis plugged in by my bed that just always stay there. I have one in a bag that I have ready to travel with extra cords. And then I have this one, which we call my mobile one, that goes in the library bag. So it is also known as the library bag Pi. And that's what I carry around on a day-to-day basis, whether it's moving around the apartment or taking with me, out when I go. But size is something that I think I'm less sensitive to, just because I think it's amazing. It works, so who cares? But that's something I hear a lot from both people who have closed the loop and are working on making it smaller and more easy to carry with them, but also people who are looking at it, they're like, I'm going to start working on it, but I'm not going to take it out until, I'm ready I can find a way to make it smaller. And that's something important too, is that a lot of people say, well, it works for you, but it's not going to work for me. And it's like, I'm sorry, it won't work for you. It might. You don't know until you try it or you investigate it. But this type of thing, it doesn't have to be for everybody. I used to say, if we only help 3 other people close the loop and they have a closed loop for 3 years, every hour, we've spent countless hours on this, every hour we've invested in this process and helping other people will be worth it. To know that now we have 25 plus people who also have this and are running overnight and feel better going to sleep and are getting better outcomes, and, however you want to measure it, that's beyond anything we could have expected. And it's been, 6 months to a year with that. So I'm really excited to see kind of where this goes in the next year, especially as more people come on board. And that's why I'm really excited to have so many people engaged in this conversation and chatting with us, on Twitter and online, and checking out openaps.org, because you might know exactly how to solve the battery problem, to make it have less battery consumption, or to replace the Raspberry Pi. And by all means, jump in. We love ideas. We love suggestions, because maybe you could do something. Maybe we could help you test it. Maybe somebody else can do it. But this project has been able to evolve and get so much better because of contributions from so many people. And I think that's one of the phenomenal things. It's not just Scott and I did everything by ourselves. That's absolutely not the case. It's been in partnership with the community and standing on the shoulders of people who did something before us. And you'll see people stand on our shoulders and do something else. And that's just really, really cool part of this. It's not a commercial entity. Nobody's in this for money. We have not made any money. This is just something that we believe in, works for me, and we want to help other people.
That is fantastic. In the chat room right now, Sarah is wondering if you have eliminated lows for yourself using this.
Yes. So I, not 100%, but I get less than 1% lows overnight and in general, which just for context, if you look at DIYPS.org, you'll see me talk about my experience before DIYPS and after. Before DIYPS, I was testing 12 plus times a day. I had a CGM. I was working really hard, but I was only in range about 50% of the time. With DIYPS, that wake me up at night system, I got to about 80% time in range. Now with the closed loop, because I already had that much improvement, you don't see that big of improvement in terms of kind of that time in range. I tend to run between 80 and 90%, but you do see that reduction in lows. My A1C is better, and it's a lot easier overall, but also just the quality of life during the day. If I start to go up at the end of a meal, or I start dropping for no apparent reason, the system's going to kick in sooner than I might notice. And so it's not just about, I've mostly eliminated lows. I've cut off a lot of highs. The standard deviation is around. It's just that it does it a little bit sooner. So even if I do drop low, my probably my low below 70 is like 0.0001%. Like that rarely ever happens. Lows for me now might drop into the 70s, but the other interesting number for me is the number of times I have to treat with sugar to eat a snack or to something is significantly reduced, because by the time I might hit 75, I've got negative insulin on board that's going to bring me up. So I don't actually have to do anything other than to just watch it and be extra careful. And so not having to eat all that extra sugar unless I want to is really a very, very nice change.
Yeah, that's huge. Just for comparison, like roughly how often did you used to have to treat with sugar? How often did you used to get hypo? And how low would you go? Sort of what was your lowest or an average low for you before starting the system?
I would have to go back and pull that number. I don't know offhand. I would frequently go into the 60s to 50s. I've never passed out or had a problem. I could always treat by myself, but frequently combination of I would walk to and from work. So depending on when I ate, when I walked to work or from work, add an exercise, add an insulin, add in the 12-hour exercise, hypo delay, I would end up waking up in the morning because of my alarm, and show my CGM had me in the 50s all night. So that was frequent before I had the manual alert system, let alone before I went to the closed loop. And so it was DIY-PS alone was very night and day for me. It changed a lot. I didn't with DIY-PS because I had alarms that woke me up at night. Yay. That was pretty great. So I stopped seeing those like really long, bad, 50 or 40 lows overnight. For me, I didn't see that much improvement going to the closed loop. But that, hey, I might be in the 60s for an hour before I woke up became, I might hit 69, but most likely I might hit 75 and then bounce right back up and level off based on the system adjusting my insulin.
We have a couple of people in the chat room right now who are actually using closed loop systems.
Woohoo.
And are also saying that they've had a lot more stable blood sugars, particularly during the night, far fewer lows at night, which is so priceless because that's kind of the thing that we all fear so much. I mean, it disrupts sleep for one, but it can be incredibly dangerous. What Terry in the chat room is asking, what is your target blood sugar during the night now?
So I'm actually toying with changing it. We started with making my target fairly high, like 120 or 130, to see what the system would do and to give me a fairly big buffer, because my ratio is 1 to 10. So if you set your target at 120, that gives you an extra unit buffer to deal with before you even get near the 80 mark. But I've over time dropped that down to about 115. And because of some changes we've made to the algorithm, I'm actually toying with dropping it to about 110 or 105 because I've seen really great success where I'm really below 90, and I feel like I've got that little bit of buffer and that little bit of fine tune, plus again, the backup systems, that I might drop it a little bit more. And so a lot of people are shocked when they hear, oh, you're targeting 120 or 130. That's high. But again, this is on top of what you might do if you're awake. If you're awake, you can obviously override that, do whatever you want, target yourself with a correction bolus to 100 or to 80 or whatever you would want to do. But because you design the system with safety in mind of what's the worst possible thing that could happen, and knowing your sleep and knowing that I sleep through things, you design it so that you want it a little bit higher so you've got that buffer. I did expect, because of that higher target, when I first started the system, I expected, man, I'm gonna be running, like 150 or 160 if I'm, not getting enough insulin overnight. That was rarely the case. Even if you, turn on the system and you start out high, maybe you're 150, 200, 300, and you're just riding flat because you're resistant for whatever reason, the system actually will take into account the amount of time you've been high, the fact that you're not dropping and it thinks you should be based on the insulin activity, and then give you more according to that. So it kind of pays attention to all those different scenarios. So it would be unlikely for you every night to be riding flat at 150 unless your ratios are just really, really off. And that's also the kind of thing that's interesting is with this system, if something changes in your body, it's that time of the month, you've been really active lately, your ratios just need to change. We don't have it automated yet, but I think there's a lot we can do with things like Night Scout where you can visualize what's going on between insulin, carbs, everything else to say, hey, you might want to think about changing your basal rates 2 hours prior, or you might want to think about, changing your ratio because you always go low, or that meal is really not 60 carbs, it's probably like 40 and you're always overdosing for it. So you need to kind of pay attention. So we're not there yet in that regard, but I think now that we've got all the data, we've got lots of people testing, it'll be more interesting to kind of dig into that and see, can we now do some predictive, retrospective analytics to say, hey, you might need to change your setting. And I think this is especially relevant for those who are still growing, especially kids, because their ratios are changing all the time. So how great would it be to alert the parent that says, okay, every 12 days, it's time to change the basal rates, or is it 7 days, or is it, 3 weeks, whatever that number is, to kind of say, it's time to do it based on what's actually happening with the body's responses to insulin and carbs, and not just, we're going to check once a week because that's what we put on our calendar. And I know that's really exhausting and burdensome. So I think there's some things that we can learn from paying so close attention to the data, that can be applied to kind of bigger situations. And then even if somebody's not running the closed loop, but they're using Night Scout, they've got their insulin data from the pump in there, they've got their CGM, they're entering into Care Portal, they might still be able to use some of this retrospective analysis that we're learning from kind of this bleeding edge work. And that's been a theme that we've had, Scott and I in particular, from working with DIY-PS, is we very quickly started learning some things because we were so immersed in the data that are relevant to people, whether or not they have a CGM, whether or not they have a pump, but it has to do with the insulin timing when you eat food. There's something we call carb absorption rate. There's a lot of things like that that we've been learning that are relevant and can be shared and potentially taken on by somebody else, regardless of their use of technology, whether they're looping or not. And that's the other thing that's cool, is because traditionally you expect to hear that from your doctor or your CDE or your nurse. But we're starting to see more of these new ideas and new ways to treat that are highly effective come out of the community. And that's something else I want to see foster, is find a way for that to then go back into the medical community so that they can learn from what we're learning. And it's not just them, whatever studies they happen to do. It's here's what's actually happening based on the data from the community. And I think that's kind of cool and kind of powerful.
We have in the chat room, somebody is asking for a quick summary of what Night Scout is. You've referred to it a couple of times, and not everyone is familiar with Night Scout.
Yeah, sorry about that. So Night Scout is a remote viewer for BGs based on CGM data. So this was before Dexcom Share or MiniMed Connect came out. Same group, the same piece of code that enabled us to do DIYPS actually led to the development of Night Scout as a way for parents to see what their kids' blood sugars were at school or wherever it was. But it's an open source, it's a similar open source project. You may have heard of the CGM in the Cloud Facebook group. That came out of the Night Scout community. And it's just this really cool platform that has all these plugins and features and all this kind of cool stuff that's come out of it. You can use it just very basic. You can use all this experimental features. But it's just really neat that again came out of a true need of, we need a way to see our loved ones' blood sugars. And again, that could be an adult who, I lived by myself in Seattle for 5 years before I got married. I didn't live with anybody, and my family was in Alabama. So that was the other thing behind DIYPS, is I want somebody else a way to see my blood sugars. And before Night Scout, that wasn't possible. And so Night Scout's made that possible for so many people. It's also led to the faster approval of things like the Dexcom Share, as well as the MiniMed Connect. And so it's kind of cool to see that evidence-based community effort driving changes and faster approval in the actual commercial products. So you're kind of starting to see a closer connection between what we're doing and what our needs are and what the companies are able to do, because we are so loud and vocal about, here's the problem, there's no solution, so we're going to build it. So there's obviously a need here if this many thousand people are using it. And that's kind of a cool phenomenon that you've seen more and more. And that's why you hear Night Scout as such a great example of that, because it did come from that community need.
All right, switching to some more questions from the chat room. We just got a few. The carb, let's see if this question works for you. The carb absorption, using the GI or something else for that?
Excellent question. And for the person who's
explain what that question means.
Yes. I will start by saying I've written more about this on DIYPS.org. So for the person who asked this, check that out. And I'm happy to continue this discussion later in more detail. The short answer is, we realized that you could observe an effect of, after a certain period of time, when you eat fast-acting carbs, your blood sugar starts going up at a fairly consistent rate. And you're probably familiar with the 15-15 rule. Test your blood sugar if you're low, eat 15 grams of carb, wait 15 minutes, test again. The reason that is because on average, your carbs are going to kick in by that 15-minute point. So you want them to kick in before you test again and decide whether to treat. But what we discovered is that line up of the carbs kicking in happened at a fairly consistent rate. And so we started kind of playing around with it and realized that those carbs absorbed at an average pace over the course of an hour. For me, it's about 30 grams per hour. And the reason this is so important is because if you sit down to eat a really big meal, say 120 grams of carbs of gluten-free pizza, which I did for the sake of science, I did it for you, or Thanksgiving dinner, or it's your birthday dinner and you've got a lot of carbs going on, a cake and whatever else, and you've got a lot of carbs stacked up. You might need 10, 12, 15 units of insulin for that meal. But if you do it all at once, that insulin kicks in at 60 to 90 minutes, you will go low. Without question, you will go low, because that much insulin will kick in at 60 to 90 minutes. And because of the carb absorption rate, your body will actually be absorbing those carbs and influencing your blood sugar for hours at a time. So with the example of 30 carbs per hour and 120 carb meal, that's 4 hours. So if your insulin peaks between hours 1 and 2, and you don't have more insulin coming later, you're going to go high in the last 2 hours. And you might think, oh, it's because I went low and then I corrected and then I went high. It's no, you still have 2 hours or 60 grams worth of carbs kicking in at that later period of time. So carb absorption rate is about understanding what is the total time that meal is going to take to absorb in your body, and when does your insulin need to be timed. And that's why you have the square wave, dual wave, combo wave type thing. But for me, what I do manually is I say, here's what I need for the first hour and a half, 2 hours. And then I'll use my system to give me a reminder of, okay, half an hour in, I want another burst of insulin to hit for the next tail, and then the next tail and the next tail. So carb absorption rate is a way to think about for that really big meal, how do you space that big amount of insulin that you know you need, but over the right period of time. So I know for a lot of people, that's a lot of information, a lot of math. So I've tried to write it up in English to look at with some examples on DIYPS.org. But the other thing too is just, you can trust it and decide if it works for you. It works for some people. Some people feel very strongly that they react to GI. I react to just about everything on average. As long as there's a mix of carbs, it all works about the same for me if I'm eating some kind of mixed meal. Other people are more sensitive to GI. And so that's kind of the thing, an example of, I would love to do more studies and have people share their experiences and say, yes, it's an average of 25 or 40 or 30 for me. So the average, and figure out what the average person is. So if you don't do the test, you can at least start with a benchmark of 30 is about average for the average person. Or if you see this happen, you're more likely to be sensitive to GI than this idea of average carb absorption rate.
Wow.
Sorry, I know that's a lot.
It's fantastic though. Terry in the chat room is asking whether using this system, you're doing any early pre-bolusing, meaning not a regular pre-bolus, but even sooner than that, like an hour out before a meal to try and get things going that far sooner.
Yes, and I feel like Terry must have read DIYPS.org, because that's the other thing that you hear me talk about a lot is what we call eating soon mode. The idea of pre-bolus is often do your meal bolus or part of your meal bolus 15 minutes ahead of time to get your insulin going a little bit faster. What I found, because I'm gluten-free, I have celiac, there's a high risk that my food is not going to come out on time. It's going to have gluten in it. It's going to be icky, or I'm not going to eat it all. And so it was really hard for me to nail the pre-bolus. But we started observing, even if my blood sugars had been perfect all night, if I had carbs in the morning without insulin activity beforehand, especially if I had been on negative temps all night before, I would just go skyrocket up. And I would need a higher percentage of insulin than I did for lunch or dinner when I'd had insulin activity in my body. So what we've learned is that you have a really strong reaction to carbs because of your liver and everything going on with meal absorption. And that changes depending on whether you've got insulin active in your body or not. Usually, if you have your standard basal rate right, that's good enough. But if you've been, after school soccer practice and you've temped to 0 for an hour and you go to have a snack and your insulin levels are effectively negative for your body, when you eat that snack, you're going to go up a lot higher than you would otherwise because the dynamics in your body are different. So what we started doing is establishing this eating soon mode where up to an hour before the meal, I'll do a little bit of insulin, but it's not about what I think I'm going to eat. It's about taking my target of 100 or 120 and dropping it to 80, which for me is about a half unit difference. And so I am not trying to shoot myself low, but I'm saying I can give this a little bit of insulin and be safe because I'm targeting a normal level, 80. It's going to take 90 minutes to kick in, but if I do that an hour before my meal, that insulin's going to be kicking in as I start eating. So then I can do my normal meal bolus minus that amount that's active, but I can do my normal bolus and not need a bunch of extra because I'm going to go straight through the roof because my body's freaking out because, oh my gosh, carbs and you have negative insulin and all this stuff going on. So if you hear me talk about eating soon mode, that's what I mean. It's not about the certain amount of what your meal is. It doesn't matter what your meal is, but the goal is to get your insulin activity peaking about the time the carbs go in. So the carbs and the insulin match there and it's not delayed by about an hour. Because if you do your insulin when you eat, the carbs kick in at 15 minutes, it's going to take up to an hour for your insulin potentially to kick in. And so that's why you tend to see that rise and that meal spike and then the insulin kick in. So what we're trying to do is better match a little bit of insulin for that first bit of carbs just to get it going. And then you could do the rest of your insulin and that's going to better match the rest of your meal. And so yes, I try to do that. Don't always do it, but generally 30 to 60 minutes tend to work really, really well for me.
Fantastic. Here's a fun question in the chat room. Has this completely freaked out your doctor?
No. I first went into my doctor when I had developed DIYPS and I had been using it for about 2 months. Was already seeing drastic improvements in terms of my time in range, my average blood sugar. I knew my A1C was going to be better. Walked in and he had my A1C and he's like, oh, seems like you're doing good. And I said, yes, I built this alert system. It wakes me up. It can alert my boyfriend or my family in Alabama. This is really great. And he's kind of like, okay. And I was like, what? I have hand built this amazing system. It's totally changed my life. And all you say is okay, what? So he didn't really have a reaction for it. I don't think he understood the significance. So in the course of the next year, we didn't really talk about it because, what did he need to do? He was just mostly ordering my A1Cs and writing my prescriptions. So by the time we got around to closing the loop, I had a closed loop artificial pancreas. It's automatically adjusting my insulin overnight. My doctor technically didn't know about it for a while. And it was about 3 months after I'd done that before I went into my next doctor's appointment. And I went in and explained, and he paid a little more attention. And he asked 1 or 2 questions. He's like, I don't think there's anything, available on the market. No, there's not. And he's like, and you built this? Yes. He's like, you wrote the software? Yes. He's like, I'm glad you're as engaged as you are. And I wish I had other patients as engaged in their care. And that was about it. He's happy I'm getting good results, and that's about it. So I think had I had a different relationship with my doctor, or he had a different personality, he might have freaked out or been way more excited about it. What I think is cool is there's a lot of other people in Open APS who their doctors are super supportive and super engaged. We actually have one doctor who wrote it into somebody's 504 plan to send it to school with them for their kid, which I think is phenomenal that it's required for him to get to use his artificial pancreas at school. So there's some doctors who get freaked out. There's some who are just kind of like, you realize this is off label, right? And others that are totally supportive, which is, your endos kind of run the gamut. It always cracks me up realizing that I don't think he understood the potential of what it is, or, how it's kind of taking off in the community, but it is what it is.
It does seem like, for you, it seems like that might have been a really surreal moment when you tell your doctor, like, hey, I built a closed loop artificial pancreas system. And he's like, neat. Let's check your blood sugar. That's pretty surreal.
Yeah, I think having gone in and done that with DIYPS when it wasn't a full closed loop, but it was like, and when we first built DIYPS, we thought it was really cool. It wakes me up, it alerts me, we've got these predictive alerts. It's basically an open loop system, but at the time we didn't think of it as this open loop. We just thought this really cool predictive alert thing. So maybe I didn't describe it great, but it was a little bit of a weird moment of him just kind of being like, okay, do you get less lows? Okay, fine. What prescriptions do you need? So it was a little bit of letdown, and probably influenced how I didn't tell him right away that I was working on closing the loop or that I had closed the loop. Because to be honest, I'm very fortunate that I don't need a lot for my endo other than prescriptions and A1C and a basic check-in every now and then. If my health changes, that might be different. But it's also like, we are sent home from the hospital or clinic or wherever you're diagnosed with a bottle of insulin, a syringe. Maybe if you're lucky, you get a pump right away, but you're given this and you're given some numbers and a sliding scale, and you basically say, the rest of your life is a science experiment. Good luck. And you start tweaking, you figure out what works. So from that perspective, this is just automating the tweaking we do to our basal rates, to our, our boluses and things like that. It's not, it seems amazing, and I think it is amazing. I'm obviously biased, but when you really think about it at a very simple level, it's what everybody does when they sit down for a meal, or what they would do if they woke up at night. Oh, I'm rising, I need more insulin. I'm dropping, I need less insulin, but it's automated. So it's mind-blowing, but it's also really simple when you think about it. And for those who are looking at the reference design, you might be thinking, wow, this is really basic and really simple. But that's kind of our point, and something that we've learned in this process is that it doesn't have to be rocket science. It doesn't have to be complicated. And that's one of the things that's kind of changed my perspective about what's coming through the clinical trials and what's going to be coming to the market commercially. Is it doesn't have to be a black box. Like, I deserve to know, why is the algorithm making this decision? What does it do if you get a compression low? I know what my system does if I do get a compression drop, or I get question marks on my sensor and how it recovers, but it shouldn't be a black box that we put on our body and just have, blind trust. Like, we need to know, because we have to choose with this type of loop system whether to intervene or not. So that's really changed my perspective on, do I think I'm going to be a first adopter of something that comes out commercially? Maybe, because I want to compare it to what I have, but do I really think it's going to kind of meet all my needs like my system does, because I can customize it and make it as aggressive as I want and set the thresholds however I want? That may be different. But I also think it means that's a conversation we need to have with the FDA, but also these companies, to say, like, look, yes, you have to build for, an average person, but for the savvy person who wants to know more, just put it on a different menu. That doesn't mean don't put it in the pump. It means put that view or that screen on a different menu where I can turn on that feature and have access to that information that I need. And I think that's kind of a dynamic that's going to need to change. And that's something, especially you'll hear Ben West talk about. He's the one who's done a lot of this amazing device work, but he talks about, he did that so we could understand how the devices work. How does the pump dose insulin? How does it communicate with your meter, or, in future, our smartphone? Like, we deserve to know how our devices work and how they communicate. So that's something I think you're going to see more and more of, and that's something I'm going to be exploring more and more of, and hope others do too, is having those conversations with the FDA and the device company to say, we deserve this information. Again, maybe not on the home screen, not for the average person, but that doesn't mean you can't have it available to the people who do want to go more, who do want access to that additional data or that knowledge of what the device is doing.
And speaking of devices coming out in the future, we talked earlier that you keep track of artificial pancreas work and research that's being done, and you have some thoughts about what's coming down the pipeline. Could you talk a little bit about what you think is we can look forward to from all the APS work?
Yeah, and I'll be curious to look back at the chat later and see other people's opinions too, but from what I can tell, it sounds like Medtronic 670G is going to come to the US first in terms of being approved based on the trial they've had, and the trial they're continuing this year. I think followed by that, we'll probably see maybe Bigfoot, or Type 0, because they've got a big pivotal trial that was just announced, and then also the bionic pancreas. But I think this is all depending on actual physical makeup of the device, funding for their trial, and then kind of usability studies to make sure that it's something that the average person can understand when they put it on and use it, to like what I talked about before about not making it a black box. I think that's why Medtronic will come out first. They've got the physical pump device. People are used to it. They've got the sensor, so they're kind of ready to go in that regard, plus making it the closed loop system. That being said, I don't think the first generation of closed loops that come out are going to be for everybody. Even the super excited, savvy, early adopters may not be happy with it, because I imagine it's going to be more conservative than what you would want to see. So you may not be able to set your target to 100. Like I talked about earlier, setting it to 130 when I started, that might be the lowest we could set it. I don't exactly know what that's going to be, but I have a feeling it's going to be the second generation, or the second group of folks to the table who have stronger customization options, to make you to be able to tune it to be more aggressive and deal better with meals or exercise or whatever it is that's kind of like your focus area that you really want to nail with the closed loop system or the hybrid closed loop system. So that's kind of my perspective on it. I'm excited to see these people in trials coming to market. That's something people ask me all the time. They're like, oh, are you going to patent this? Are you going to sell it? Are you going to XYZ? No, because we're kind of filling in the gap between now and having something come out to market. We don't think that everybody is going to want to carry this around. We know that's not going to happen. And we also know it's not the absolute best form factor or anything else. But it's an option for people, and it's also helping people decide this is kind of how the system is going to work, a basic system. And might help them choose from the commercial options available, and might also help educate them to better, even without a loop, take care of their diabetes if they learn something from what somebody else has learned from. But we don't expect to be a commercial organization because we all have day jobs. We're doing something else. But it's kind of interesting because a lot of people think, oh, you should patent, you should sell this, you should commercialize it. If we did that, we wouldn't be able to do what we're doing, which is enable other people to go build their own, today. We have 25 people running today because we're doing it as an open source effort. And so I wouldn't trade that, for the world. And I'm happy to, donate our time and our energy like we have over the years to do that, because I think that is filling an important gap between now and having the first option come to market, or several options come to market in the next couple of years, and getting to a point where the technology, the average piece of technology that comes out is going to work for a larger group of people. But I think it's also, we've got to manage our expectations of this device that comes is not going to be a magical cinnamon cure. It's not going to be perfect. You're still going to have to deal with insulin pulling. You're still going to have to calibrate the CGM, and deal with the frustrations of having a device on your body. There's still that kind of basic stuff that even with a closed loop, diabetes is still there. Sometimes it still sucks. It's just going to suck less. And that's at least an improvement.
Sucking less is definitely an improvement. So we're almost out of time, but we have one final question in the chat room, and that is, given what you've said about not having any interest in patenting what you've created, that it's important that this is entirely a community-based endeavor, so that it stays something that's accessible to people. Given all of that, though, have you had any conversations or communications with pump companies or CGM companies, not around selling what you have come up with, but just have they approached you to talk about what you're doing?
Yes, we have approached them. They have approached us. We've had conversations with Dexcom and Medtronic and other companies as well. Our dream would be for some company to take our algorithm and basically make it interoperable. So you can choose the pump you want, the algorithm you want, and the CGM you want. Because right now I'm using a Dexcom CGM, our OpenAPS algorithm, and the Medtronic pump. But I would love for somebody to be able to say, you know what, Omnipod works for me. I want tubeless. Great. Take your Omnipod pump, take your Medtronic, your Libre, your Dexcom sensor, whatever it is that works for you, and then plug in whatever algorithm. So my dream would be able to get this algorithm used by, an organization, a company who would then, either tie it to their system or make it so that you could pick and choose from it. That would be amazing. But yes, we're talking with Medtronic about how to make their products better, including, when their product comes to market, it's too late to make changes in that product. So how do we start talking to them now about the 670G and what's coming out in the market in the future and kind of beyond, and saying this is what's going to be important based on this kind of bleeding edge work that we're doing. We're not saying design the perfect system for me or for the people who are really willing to do all this work, but from what we've learned investing so much time in this, for your system that comes out, you're still missing some key features or some key XYZ, and you need to be aware of what that is and make a better product. That's what we want them to do, is make a better product to give us more options. So that's kind of where we are too, is in addition to, I've got my system up and running. We're trying to support the community for more people to build their systems, but also have the conversation with anybody who's willing to do that. So if you work for a company or know somebody, by all means, please make an introduction. We've talked to Dexcom and Medtronic primarily, but I'd love to talk to some of the other manufacturers, startups, organizations, whoever. So just let me know. I'm happy to talk to whoever, because we'd love to see everybody's devices, whether it's an open source project like this and Night Scout and that kind of thing, or the commercial product that comes to market and gets FDA approved. We'd love for all those to be better.
And for that, you're getting a standing ovation in the chat room.
Thank you, everybody, so much. And I tweeted some links and examples earlier. So if you want to check out on Twitter, #OpenAPS, the reference design, openaps.org. It links to our docs. My email is there, dana@openaps.org. I'd love to talk to you guys more. So please follow up if you have questions or are interested.
Awesome. Dana, thank you so much. Truly, in the chat room, folks are saying that they are in awe of you and of the incredible work that you have done and are doing. And thank you so much for doing it and for spending some time with us here today to tell us what it is.
Yeah, my pleasure. I'm happy to represent the community of amazing people who's made this possible.
Nice, nice. Thanks so much. Have a good day.
Bye, everybody.
Bye.